All right, so what we're doing here is I want to show how to use one of these meters here. To start, you'll notice it's got a variety of options down here. These two in amps are for current that we're not using for this lab. These four here, 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 and here are for voltage. And the idea is you want to use whichever of these ranges, 0.1, 2, 10, and 500, is appropriate. And the idea is if you pick a range that's too small, the needle will go all the way to the other side and hit the wall, and that's said to be pegged, and so that's bad. However, if you pick a range that's too big, the needle won't move very much at all, and you won't get a good reading. So the idea is you want to pick the range that moves the needle the most without pegging it. And I'll show you what that looks like. So if you had no idea what your voltage was, you would start at the highest, 500. And these buttons you just push down like that. You'd start at 500. You'd watch the needle. And if the needle barely moved, you go, okay, let's try 10. And you just keep working your way down until you find the right one. Reading this can be tricky too. So for example, if you were using the 10 volts, that means you would read the middle scale from 0 to 10 and ignore the other two. If you're using the 2 volts, you have to read the bottom scale from 0 to 20, but you have to realize your range is from 0 to 2. So, for example, if the needle was on the 20, that's not 20 volts, that's 2 volts. So when using this, you have to read this bottom scale and divide by 10, and there's a good chance you'll be using it for our lab. If that doesn't work, you have to use the 0.1 volt, which takes us back to the middle scale, but you have to realize we're going from 0 to 0.1. So if it was on the 10, that's 0.1. If it was on the 9, that would be 0.09. And we'll be using one of these two for the lab. So let me hook something up just to show you what this looks like. So, 2 wires. People get really funny about the wires. People like obsess over the colors. The color is just the plastic coating. So the fact that this one has black plastic and this one is red plastic has nothing to do with it. So you don't need to worry about that. Sometimes it can help you keep organized, but it's not like you have to plug the black wire in there and you have to plug the red wire in there. I will, just because it looks good, but you don't have to. Then I want to hook the 2 ends up to something so we can measure a voltage. So let me get these out of the way of the camera. And let me take something that we know as a good example to practice with. And so I will take this generic battery. And this battery should be right around 1.5 volts, maybe a little more. Often these are right around 1.6. And then that goes down when they start to go bad. So I'll just put the battery here. And it's going to roll away. So I will move my keyboard so it stays there. And let's just try something. So let's try the 500. And I'll stick this on each end. So one here, one on the other end. And it's hard to see, but the needle barely moves. That means our range is way too big. So now let's try the 10. Okay, that's pretty good. And so since I'm using the 10 range, we're going to read the green one. And this one you read normal. And you'll see it's right around 1.5, maybe a little bit higher than 1.5. Let's try the 2. Oh, there we go. Now it's really moving the needle, but not too far. So again, that's that. So since we're using the 2, I'm going to read this bottom scale, 0 to 20, but realize I have to divide by 10. So it, according to the scale, is a little above 15, almost 16. But again, divide by 10, so about 1.6 volts would be there. Now, if I go here to the 0.1 volts, it's going to be way too much, and I want to show you what happens, but I'm not going to leave it on for very long. You'll see the needle will jump to the other side. So it actually hits the other side and crashes, and that's not good for the meter. So if you ever do this, you don't want to leave it there because it can ruin the needle. It can also mess up the electronics inside of this, so you don't want to do that for very long. So in this case, the best one is, no surprise, the 2 volt range, because this is a 1.5 or 1.6 volt battery. And this is what you're going to use. Now let's say that you have your wires backwards. So let me switch these on the battery. You'll see, no surprise, the needle will go the wrong way. Again, watch the needle. It goes the wrong way. So you can't read it. There's 2 ways to fix this. I could switch my wires like that to the other sides. Or if you already have your, let's say you've got your battery all set up and you've got this fancy thing set up and you don't want to mess with your wires, instead of moving your wires, you can just leave them like they are, and you can just hit this polarity button. So you push this, and that will internally switch the wires for you, and now it'll go the right way. So that's how that works. Now you might think, why are we using this old funky meter with the gauge? Why don't we use the fancy modern meter like this one? Well, first of all, if you know me, I like the old school equipment. I think it's much better for education, even though this is a better tool. The other problem with this is this thing can give you numbers that you don't understand. So for example, first you have to know how to work this switch, and this switch goes many different places. And so for example, even right now, I've got nothing hooked up to it, and it's throwing numbers out. So the problem with this is because it just throws numbers at you, you can be reading something that is completely wrong, and you have no idea that you're doing it totally wrong. Whereas this thing, if the needle doesn't move, or if the needle goes too far, you know something's wrong. And if the needle moves the other way, you know something's wrong. This one I think is a bit more intuitive, even though you have to read the needle. But I can show you this one. If we were going to do this one just for the heck of it, same idea. I'll get this one out of the way. Plug my wires in. Since we're doing this, I might as well do this one too. We've got current, voltage, and that's resistance, but we don't really cover that in AP chemistry. It's more of a physics thing. And so I'm going to go over here to voltage. It's probably hard to see, but there's like a little notch right here on that side. And that notch, there's a lot of glare. The notch tells me where it's pointing. Think of that as like a little arrow right there. And right now I'm at 20 volts, and it's the same idea. That means it's going to go from 0 to 20 volts. So if I turn it on and I hook it up here, first of all, it says negative. So I'll just switch my wires back. And there you go, 1.67, which agrees with the other meter. But here's the problem. If I go to resistance, let's see if I can get it to read something here. It doesn't have much of a resistance. I can't even get it to read anything. Well, there we go. See, I'm actually getting a value of 2.0. And this might trick you into thinking that that's the reading. So you need to know which of these to use. You also need this switch in DC. And then you got to know where to plug in over here. So you got to know which of these 4 things to use. So that's why I don't really think this is the best for us, even though it is a better tool. If for some reason during the lab you can't get this to work, let's just say it is just not working for you, I will have one of these and I can help you use it just in case we need it. But anyway, back to the one that I like. You'll be using this, and you'll either be using the 2 volt or the 0.1 volt, depending on the battery that you decide to make. And yeah, there we go. If you want to practice, I have a bunch of these. So if you want, during the lab, you can borrow a battery from me, and you can practice with that. That way you know if you're using this right. And that should do it.